Dear students, so till now we have discussed about the difference of means. Means when the samples are of independent. Then to test whether there is a significant difference in the population means, we have used the students' t-test for difference of means. But here, when the samples are here dependent, right? That means for the same sample, when we are applying the before and after techniques here, then to test whether there is any significant difference before and after training or before taking drug and after taking drug. So that also we have to test when the sample size is less than or equal to 30. Then for that we will use the paired t-test for difference of means. So if you see the first problem, 10 workers were given a training program with a view of study their assembly time for a certain mechanism. The results of the time and motion studies before and after the training program are given below. Test whether there is a significant difference in assembly times before and after training. And the tabulated value of T for 9 degrees is given as 2.262. So here the number of workers are 10 workers. So before training and after training. Before training it is 15, 18, 20, 17, 16, 14, 21, 19, 13 and 22. And after training it is 14, 16, 21, 10, 15, 18, 17, 16, 14 and 20. Now here they are asking you to test the significant difference between the assembly times for before and after training here. So as we are well known that H0 is always mu1 equal to mu2, where mu1 represents the time taken in the assembly for before training and mu2 is the time taken after training here. Then again is to H0, H1, it is given as here. So here the performance of the assembly times, it depends on the worker, whether they are trained or not, it depends on their capacity of the doing work here. So here it is mu1 is not equal to mu2, means it is two type. Then under the null hypothesis, the test statistic is given as T equal to d bar by capital S by root n follows a T distribution with n minus 1 degrees. Now here n means here the number of observations. We have 10 workers here. Now d bar we have to calculate, where d bar is given by the formula summation of di by n here, and capital S is given by the formula square root of 1 by n minus 1 summation of di minus d bar whole square. Now to find out the d bar and capital S, first we have to know the difference between these two, right? So the difference between those two can be obtained by taking here, so before and after. So before means here 15, 18, 20, 17, 16, 14, 21, 19, 13 and 22. After means here 14, 16, 21, then 10, 15, 18, 17, 16, 14 and 20. Now we have to find the difference between these two. That is the deviation here, di. So 15 minus 14 is 1, 18 minus 16, 2, 20 minus 21 is minus 1, 17 minus 10, 7, 16 minus 15, 1, 14 minus 18, minus 4, and 21 minus 17 is plus 4, 19 minus 16, 3, 13 minus 14, minus 1, and 22 minus 20 is plus 2 here. Now, the differences can be negative. So here we have to find the mean of these differences and the standard deviation of this. So that we can do using the CalC and the regression linear mode here. Now if you see here, we have to give the differences in the regression linear mode. But some of the differences are negative. So wherever we are finding the negative, for that we have to use the minus within a bracket symbol, that is just above the RCL key here. So we are already in the regression linear mode. Now start giving the values. So 1 m plus, 2 m plus, then minus 1 we have. So press this minus within a bracket symbol and 1 m plus. Okay. Then 7 m plus, 1 m plus, minus 4 again. So this symbol and 4 m plus, then 4m plus, 3m plus, again minus 1, so this symbol and 1m plus and 2m plus. So total 10 observations are stored in the calc. Now next press shift 2 here. Okay. Now we know that the formula for d bar is here summation di by n. So here if you press the shift 1, so summation x means here summation d, that is given by 14. So 14 by 10, of course it is 1.4. Now capital S, here we have a formula that is square root of 1 by n minus 1 summation di minus d bar square. So if you press the shift 2, we have a third option, that is capital S. So the value is here given by 3.0258. So 3.0258. Now substitute in the T formula, that is d bar by capital S by root n. So 1.4 by 3.0258 by square root of 10 here. So that means here first we have to find root 10, then 3.0258 divided by the root 10 is 0.9568. And here d bar is 1.4. So 1.4 divided by 0.9568 is 1.4632. So T calculated value is 1.4632 here. Now T tabulated value at 9 degrees n minus 1, that is 10 minus 1 is 9. For 2 tiled here, because our alternative hypothesis is not equal to, so for 2 tiled, and here level of significance is not mentioned, then by default we have to consider it as 5% at 5% level of significance. That means 2 tiled 5% means we have to look after the table value of 9 at 0.025. So that is given as 2.262. Okay, so now here T cal is 1.4632 and T tabulated value is 2.262. So T calculated value is less than T tabulated value. So therefore H naught is accepted. That means here mu1 is equal to mu2. That means there is no significant difference in the assembly times of the workers before and after training. Okay. So first we have to frame the hypothesis, then we have to write the test statistic, then we have to find the differences between the before and after training. So remember here, always the sample size will be one only, and for the same sample it will be given the data before and after. So that is the easy identification for paired t-test for difference of means. Because you may get confused about the t-test for difference of means, that is x bar minus y bar by capital S into square root of 1 by n1 plus 1 by n2 and this formula. So remember here always only one sample size will be given to you, and for that before and after will be given. Okay. So this is about the students' paired t-test for difference of means. Now let us see second problem in paired t-test. The blood pressure of 5 women before and after intake of a certain drug are given below. Test whether there is a significant change in blood pressure at 1% level of significance. Now this time they have mentioned the level of significance as 1%. So the tabulated value at 1% for 4 degrees is 3.747. So before drug, the blood pressure readings were 110, 120, 125, 132 and 125. Now after drug, the BP readings were 120, 118, 125, 136 and 121. So here mu1 represents the blood pressure readings before drug here. So obviously the null hypothesis is mu1 equal to mu2. Then against H1 here. So we know that after taking a certain drug there will be slight improvement in the health conditions, right? So if mu1 represents the BP readings before drug, then mu2 represents the BP readings after drug here. So definitely there will be a slight improvement. So that's why mu1 is less than mu2 here. Okay, so this is here one type. Now under the null hypothesis, the test statistic is T equal to D bar by capital S by root n follows a T distribution with n minus 1 degrees. Now here n means here the number of observations. So here we have 5 when 1, 2, 3, 4, 5. Now we know that D bar is summation Di by n and capital S is the square root of 1 by n minus 1 summation of Di minus D bar whole square here. Okay. Now first we consider the differences between before drug and after drug. So before and after. So before drug the readings were 120, 110, 120, 125, 132 and 125. Now after drug here 120, 118, 125, 136 and 121. Now the difference is here 110 minus 120 is minus 10, 120 minus 118 is 2, 125 minus 125 is 0, there is no difference. 132 minus 136 is minus 4 and 125 minus 121 is here plus 4. Now again we have to go to regression linear mode and we have to give these differences in the CALC. So here we have the first observation minus 10. So again within a bracket minus symbol 10 m plus. Then second observation is 2. Then third observation is here 0. Then fourth one minus 4, so again minus symbol 4m plus. Then fifth observation is 4 here. Now if you press shift 1, summation di is nothing but here minus 8. So minus 8 by number of observations are 5. So it is here the value is minus 1.6. Now capital S is here, shift to third option, right? So that is here 5.5498. Okay, now substitute in the T formula. Now T equal to D bar by capital S, that is minus 1.6 by capital S means here 5.5498 divided by root 5. So this is here root 5 is 2.2361, then 5.5498 divided by 2.2361 is here 2.4819. Now this time our calculated value will be negative because here D bar is negative here. So 1.6 divided by 2.4819 is 0.6447. So Tcal is minus 0.6447 here. Now here we can't consider the modulus for Tcal because our alternative hypothesis is less than, that means left side here. So Tcal will be minus only and the calculated value of T at 5 minus 1 is 4 for left tile at 1% level of significance. 1% is here 0.01. We have to look after the calculated value. So left tile means at exactly 0.01. So here the value is given as 3.747. So since our alternative hypothesis is one tile, so that means the calculated value of T is here minus 3.747 here. Now our T calculated value is minus 0.6447 and T tabulated is minus 3.747. That means T cal is greater than T tab. So therefore H0 is accepted. H0 is accepted means here there is no change in the BP readings before and after taking the drug here. So that means mu1 is equal to mu2 here. Okay. So since the alternative hypothesis is left side, so whenever T cal is greater than T tab here, H0 is accepted. That is the reverse conclusion of the remaining test here. Okay, so here there is no significant change in the blood pressure readings before and after taking a certain drug. That is the conclusion for this problem. Hope you understand this problem. Now let us see the last problem in paired t-test for difference of means. The memory capacity of 10 students were tested before and after trying. State whether the trying was effective or not from the following scores. So the tabulated value of t for 9 degrees is given as 1.833. So before trying, the scores were here 12, 14, 11, 8, 7, 10, 3, 0, 5, 6. After trying, the scores were 15, 16, 10, 7, 5, 12, 10, 2, 3, 8. Right? Now here, you may get a doubt that there is no average word here. So how we have to identify whether the test is regarding means or not. So generally here, whether to find the before and after any situation, the basic test we consider is the mean test here. So you see here, mu1 represents the scores before training and mu2 represents the mean scores after training here. So obviously the null hypothesis will be mu1 equal to mu2. That means there is no difference in the scores before training and after training. Then against here H1, definitely there will be a little improvement after training in the scores. That is a general fact we have to accept here. So mu1 is less than mu2. That means there is a little improvement in the scores before training and after training. Then under H0, the test statistic is given as P equal to D bar by capital S by root n follows a T distribution with n minus 1 degrees. So here the number of observations means the number of students we have taken are 10 here. Now we know that D bar is summation Di by n and capital S is here square root of 1 by n minus 1 summation of Di minus D bar whole square. Now let us consider the difference between these 10 students of the before and after training marks here. So before and here after. So before training the scores were 12, 14, 11, 8, 7, 10, 3, 0, 5, 6. Now after training the scores were here 15, 16, 10, 7, 5, 12, 10, 2, 3, 8. Now see the differences. Di. So 12 minus 15 minus 3, 14 minus 16 minus 2, 11 minus 10 1, 8 minus 7 again 1, 7 minus 5 2, 10 minus 12 minus 2, 3 minus 10 minus 7, 0 minus 2 minus 2, 5 minus 3 2 and 6 minus 8 is here minus 2. Right? Now here we have a lot of negative differences here. Now again go to the regression mode linear. Now start giving the observations. The first observation itself is minus 3. So use the minus within a bracket symbol 3 m plus. Second observation is minus 2. So again minus within a bracket and 2 m plus. Third observation 1. Again fourth observation is also 1. Then fifth observation is 2. Sixth observation minus 2. So minus within a bracket and 2. Then seventh observation minus 7. Eighth observation minus 2. Ninth observation plus 2. And 10th observation is again minus 2. Okay. Now we have to calculate the D bar. Now D bar means here summation Di by n. So that summation is here minus 12. So minus 12 by 10 is minus 1.2. And for capital S here, shift to third option. So that is given by here 2.7809. Now substitute in the T formula minus 1.2 by 2.7809 divided by square root of 10 here. So square root of 10 is here 3.1623. So 2.7809 divided by is 0.8794. Now here, this time the t calculated will be negative because here in the numerator we have minus. So 1.2 divided by 0.8794 is 1.3646. So minus 1.3646. Now we can't consider the modulus of that because here the alternative hypothesis is left tail here. So t calculated is minus 1.3646. Now tabulated value of t at 10 minus 1, that means 9 for left tiled. Okay, so left tiled at here the level of significance is not mentioned. So by default we have to consider it as, that is 5%. So at 5% level of significance is here. So left tiled means we have to place a minus sign before that. So minus 1.833. Okay. Now t calculated is minus 1.3646 and t tabulated is here minus 1.833. That means t calculated is greater than t tabulated. So that means here H naught is accepted. H naught is accepted, that means here there is no significant difference in the scores of 10 students before and after training. That is mu1 is equal to mu2 here. So that's about the paired t-test for difference of means. I hope you understand these problems. In the next class, we will discuss the problems of F distribution for variances.